Welcome back. We are on the topic rigid motion and transformation. In the previous video, we learned how to translate a point in the XY plane or the Cartesian plane. In this video, we are going to learn how to rotate a point in the XY plane or the Cartesian plane. Rotation of a point XY in the Cartesian plane. Let's consider this scenario. Let's say that we have a point here. We are going to call this point P. And we have a stone. We are going to use this red point to represent the stone. We have a stone, and this stone is tied to point P with a rope as illustrated here. When we have something like this, we can move this stone from one position to another position by rotating it about the point P. So we have a point P here, and we have this stone, and we have tied the stone to point P. We can move the stone from one point to another by rotating it about the point P. The same can be done for a point in the Cartesian plane. So we have our Cartesian plane here, we have our x-axis and the y-axis. If let's say we have a point A, and point A has the coordinates xy, as we can see here, we can rotate this point A from this position to another position by rotating it about another point. If we rotate a point or an object about another point, the final position of the point or the object depends on some few factors. Let's use this illustration here as an example. What I mean is that if we rotate the stone about the point P, the final position of the stone will depend on some few factors. One of those factors is the direction of rotation. As we can see clearly here, we can either rotate the stone in this direction or in that direction. If we rotate the stone in this direction, the position of the stone will be different from rotating it in this direction. If we rotate the stone in this direction, it is known as a clockwise rotation. And if we rotate it in that direction, it is known as an anti-clockwise rotation or counterclockwise rotation. In some books, you see anti-clockwise rotation. In other books, you see counterclockwise rotation. So just as we have it here, when we have a point in the XY plane, we can either rotate the point in the clockwise direction, that is in this direction, or the anti-clockwise direction or the counterclockwise direction, that is in this direction. So the final position of the object that is being rotated will depend on one, the direction of rotation. And as we can see here, the rotation can be done in either the clockwise direction or the anti-clockwise or the counterclockwise direction. The final position of the object will also depend on two, the angle of rotation. So the final position of the object will not only depend on the direction of rotation, it will also depend on the angle of rotation. Now let's look at our illustration here. If you rotate the stone through a 30-degree angle, the position of the stone will be different from when it is rotated through a 60-degree angle or a 10-degree angle. In our studies on rotation of a point in the XY plane or the Cartesian plane, we will consider only three angles of rotation. We will consider a rotation through a 90 degrees angle, a 180 degrees angle, and a 270 degrees angle. Now let's look at something very interesting on our Cartesian plane. In the videos on bearings and vectors, we learned that from this line to this line, the angle between them is 90 degrees. So the angle between these two lines is 90 degrees. The angle between these two lines is 90 degrees. The angles between these two lines is 90 degrees. And the angle between these two lines is 90 degrees. So from here to here is 90 degrees. From here to here is 90 degrees. From here to here is 90 degrees. And from here to here is 90 degrees. So let's say we choose this line as our starting point. So here will be 0 degrees. That is where we are starting from. So that will be 0 degrees. And we are going to move in the clockwise direction. That is, we are moving in this direction. If we are moving in this direction and we know that here is 0 degrees, you will see that from this line here to this line, we will have 90 degrees. So from here to here is 90 degrees. From here to here is also 90 degrees. So if we add 90 degrees to 90 degrees, you have 180 degrees. From here to here is also 90 degrees. So if we add 90 degrees to 180 degrees, you have 270 degrees. So moving in the clockwise direction, you have 0 degrees here, 90 degrees, 180 degrees, 270 degrees. Now, what if we move in the counterclockwise direction or the anti-clockwise direction? That is, we are moving in this direction. If we move in this direction, we already know that here is 0 degrees. So from here to here will be 90 degrees. Here will be 180 degrees because 90 plus 90 give us 180 degrees. And here will be 270 degrees because 180 degrees plus 90 degrees will give us 270 degrees. Now we can see something very interesting happening here. On this line, we have 90 degrees clockwise and 270 degrees anti-clockwise. And on this line, we have 90 degrees anti-clockwise and 270 degrees clockwise. So we can say that from this illustration, a 90 degrees clockwise rotation is the same as a 270 degrees anti-clockwise rotation. And a 90 degrees anti-clockwise rotation is the same as a 270 degrees clockwise rotation. If we take 180 degrees, we can see that both clockwise 180 degrees and anti-clockwise 180 degrees will land us at the same point. So for 180 degrees, it doesn't really matter whether it is a clockwise rotation or anti-clockwise rotation. They will all land us at the same point. But for a 90 degrees and 270 degrees rotation, we can see that 90 degrees clockwise rotation and 270 degrees anti-clockwise rotation are the same. And 90 degrees anti-clockwise rotation and 270 degrees clockwise rotation are also the same. So up to this point, we have seen that when we rotate a point or an object about another point, the final position of the point, that is the image of the point, will depend on one, the direction of rotation. And we have seen that the direction can either be a clockwise direction or anti-clockwise direction. Two, it will also depend on the angle of rotation. We have said that in our studies, we are going to consider only three angles: 90 degrees angle, 180 degrees angle, and 270 degrees angle. And we have seen that a 90 degrees clockwise rotation is the same as a 270 degrees anti-clockwise rotation. And a 90 degrees anti-clockwise rotation is the same as a 270 degrees clockwise rotation. And a 180 degrees clockwise rotation is the same as a 180 degrees anti-clockwise rotation. When we rotate a point or an object about another point, the final position of the point or the object also depends on the center of rotation. The center of rotation. In our illustration here, we said that we are rotating the stone about the point P. So the point P becomes our center of rotation. We are rotating the stone about the point P. So the point P becomes our center of rotation. Now, what if we have another point here? We are going to call that point M. And instead of rotating the stone about point P, we rotate it about point M. You will see that the final position of the stone or the image of the stone will change. So if you have a point in the XY plane or the Cartesian plane, one of the factors that affects the position of the image is the center of rotation. In our Cartesian plane, we are going to learn how to rotate a point about the origin, which has the coordinates 0, 0. And then we will learn how to rotate the point about any other point. So we are going to use A, B to represent the coordinates of that point. So we will learn how to use 1, the origin as our center of rotation, and 2, any other point as our center of rotation. So on our XY plane here, we will learn how to use the origin, which is usually denoted with the letter O and has the coordinates 0, 0 as our center of rotation. So if the origin is our center of rotation, it's like we have connected the point to the origin and we are rotating the point about the origin. As we can see, we can also have another point as our center of rotation. So let's say that we have a point D here and the point D has the coordinates AB. We can also use the point D as our center of rotation. So it's like we have connected the point A to the point D and we are rotating A about the point D. Let's go over what you have learned so far. We have learned that when we rotate a point or an object about another point, the final position of the point or the image of the point or the object will depend on 1, the direction of rotation. And the direction can either be a clockwise direction or anti-clockwise direction. It will also depend on 2, the angle of rotation. We have said that in our studies on rotation of a point in the XY plane or the Cartesian plane, we will consider only 3 angles of rotation: a 90 degrees angle of rotation, a 180 degrees angle of rotation, and a 270 degrees angle of rotation. We have also seen that the position of the image will also depend on 3, the center of rotation. And we can use the origin as our center of rotation or any other point as our center of rotation. So in the subsequent videos, we are going to learn how to rotate a point through a 90 degrees clockwise direction or a 270 degrees anti-clockwise direction about the origin or about in another point. We also learn how to rotate a point through a 90 degrees anti-clockwise direction or a 270 degrees clockwise direction about the origin or about another point. Then we will learn how to rotate a point through a 180 degrees angle about the origin or about another point, because for 180 degrees it doesn't matter whether it is clockwise or anti-clockwise. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to learn how to rotate a point through a 90 degrees clockwise direction or a 270 degrees anti-clockwise direction about the origin. Bye bye.